In this problem, we are given an object whose mass is 3 kilograms and whose initial velocity is given in I and J notation as follows. So initial velocity is equal to 6I minus 2J measured in meters per second. The question is, what is the initial kinetic energy of that body? So this is part A. Kinetic energy initial, by definition of the kinetic energy, is m v initial squared over 2. Now here, v initial is the magnitude of the v initial vector. We have x and y components of this v initial, so v initial x is equal to 6 and v initial y is equal to minus 2 in meters per second. Now we know how to find the magnitude of a vector if we know the components. We just use the Pythagorean theorem. So this is equal to m over 2 vx squared plus vy squared. So this gives us v over 2 6 squared plus 2 squared, and the answer you get is 60 joules. So this is the answer to part A. In part B of the question, we need to find the work done on the body if the velocity changes to something else. So now, let's record this. So kinetic energy initial is 60 joules. That's the answer from part A. Now we are said that the velocity under the action of that force is changing to a different thing. So V final is now equal to 8I plus 4J, also measured in meters per second. So we now can do exactly the same thing, and we can find the kinetic energy final. How do we find the work? Well, again, we can use the kinetic energy theorem, work kinetic energy theorem, which states that change in kinetic energy is equal to the work done on the body. So work would be equal to kinetic energy final minus kinetic energy initial. So all we need to do now is to find kinetic energy final. Kinetic energy final would be m over 2 v final squared. M over 2 is 3 over 2. V final squared, again using the Pythagorean theorem, is equal to 8 squared plus 4 squared. And if you do the math, this gives you 120 joules. So the work done by the external force on the body is equal to 120 minus 60, which is 60 joules.